Hi, I'm Fiona. I'm a software developer at inviCRO, and I work on VivoQuant. And what I'm going to do is introduce VivoScript and then talk about the quick access toolbar, which is in the top right, and you may have seen it or used it. First of all, what is VivoScript? A lot of people have mentioned it, so you've been hearing about it, but it's a JavaScript-based programming language. Just like JavaScript allows you to access elements from an HTML page on the internet and run operations and do certain computations behind the scenes, VivoScript allows you to do the same thing with VivoQuant. You can think of it as a remote control for the operations that you're already doing in VivoQuant, as well as adding a few other really important tools like being able to run MATLAB, access the iPACS, look at meta information, or access even internal VivoQuant functions that are inside the software. But you can also just do anything that you'd be able to do in VivoQuant manually. You can write a script that will do that as well. And so why would you do that instead of just doing it in VivoQuant? Well, if you have a lot of images and you want to do the same thing to every single one, it's a lot easier to write a script and run that while you go do something else. So it's good for batch processing and then like repetitive tasks, just like any scripting language, really. So Gabe's going to talk to you about how to go about writing a VivoScript, but something that we've been improving in the most recent version and will continue to work on is the quick access toolbar in the top right. So it used to be some like hard-coded buttons that you had to abbreviate to like 2 characters for every script that you used, and this is mainly just for scripts that you use a lot, because you might have a couple scripts that you're always trying to import, and so here now there's a drop down, so you can have as many as you want, and then there's a command prompt button, which is the eval button on the left that you can just put in like a one line that you don't want to create a file for it, and you can just run that immediately, and then you can also edit the scripts right there, and you don't have to like open them up in a separate file. Let's see. So you can also edit your list of quick scripts here, and be able to just move them around or like remove them if you don't need them anymore. And that's pretty self-explanatory: add, remove, or everything like that. All right. So I'll show you a script in action. All right, so I'm going to show you the onion tool, which earlier on we were talking about how tumors have signal dispersed throughout, and the inside might be necrotic, and so you need to look at the signal at different, like, well, not thickness, but like depth inside the tumor. So if you have an ROI, you might want to create a lot of ROIs of varying radii so that you can then like chart what the signal is inside each ROI. And so I'll do that manually first, so you can see that it would be repetitive, and you'd want to use the script. So I'll just see. Is that, oh, sorry, I can't. Yeah.
So we're going to mirror the...
Oh, no, it's doing it. Let me just... I'm just like... I keep forgetting. All right. There we go.
Now you see the transfer with on-the-fly compression, but it still takes a bit for the there.
Yeah. Well, this is a big one. The images won't really matter for what I'm doing. It's really just drawing spheres, but...
VivoQuant caches images in the local cache for a while, so once you have open data sets, the next time you request them, it will be much faster, and then you can set a certain cache size, and then all the files get removed. Speed things up further.
This is where Eli does his dance routine.
Just warming up.
All right. Where's the data?
I think we chose some really big ones.
Yeah. Those are the automatic ones. Oh, there we go. Oh, did I? Was it for plan? Oh.
So if you use the here, and,
So what happens if you try to open the projection data along with the volume layer, and then?
Oh, should I do the other? Okay. I think it was P, CT_PET.
They're powerful query mechanisms. So they selected the iPACS. You can actually have most iPACS configured in your system.
Oh, it's the other one.
And so you choose one, and then because, for instance, on our iPACS systems, we can have thousands of projects. Actually, it's a small project filter that allows you to drill it down to just the project you're looking for. And then you can download data. So that was actually downloaded from the German servers.
Yeah, it was the training iPACS, not the local one.
Better. Well, actually, not bad speed. Drinking beer already.
Right. Okay. All right. So first, I'm going to not actually draw a tumor ROI. I'm just going to draw a sphere. And I'm going to erode it twice so that you can see how you would go about creating an onion on your own. So I'm going to make it really big so that you can see what's happening. Put it there. And so now we have the erosion dilation tool, which was mentioned earlier. And let's see, this is pretty big, so maybe do the 2. And then we map the erosion to another ROI. And so you can see that created. Can everyone see the? I'll make the next one a little bit thicker so you can see it.
Can you explain the erosion?
Oh, erosion and dilation are simply adding, it's a computational way in image processing of just taking a shape and then adding, a certain thickness to the edge, or decreasing the thickness in a certain way. So for a sphere, it's just adding a concentric sphere onto it. And so here you can see the blue piece is a little bit thicker this time around, so you can see how that would work. So if I wanted to create an onion so that then I could have a bunch of ROIs of different thicknesses for the tumor, I would just keep doing this and keep adding ROIs and pressing check and then waiting for it to finish. But there's a way to do this with VivoScript, and I'm going to show you how to use that as a quick script. So I've already added it here, but if I wanted to add a quick script, I could find it in my browser, and then it would appear in this handy drop-down of scripts that you can easily add. But it's already there, so I'll show you that you can edit things inside VivoQuant. You don't have to open it up if you just want to quickly see what it is. Oh, I don't have it selected. So onion tool is what I want. I think we're on a different system, so I will have to add it. All right. Yeah.
on the desktop.
Yeah. There we go. There we go. And I can Did you have that? All right, thanks. I will use such thing, and call it onion. All right. So now that appears in the dropdown too. Thanks. And I can edit it here. So here the thickness is 3. And you can look at your entire script here. This may be a little bit confusing, but Gabe will talk about what it all means pretty soon. But something that you can just quickly see is that we're looking at a list of ROIs, which are inside VivoQuant, and then later on we're dealing with these buttons that have to do with erosion and dilation. So now that I have that script queued up, I can just run it, and then it asks me which ROI I'm eroding. So does anyone know which one that would be in this case? The red one. Okay, exactly. So now I just click that, and I'll try not to drop the mouse this time. But I click that, and now I don't have to touch anything, and it will do it for me. And so here I would have been pressing all the buttons myself, but now I can go take a walk and come back.
And I'm feeling always like I'm working if the computer is processing things. And
Like my code's compiling that. That's the same. So, and you can see them. This is why it's like a remote control, because I can sit here and all the operations are still happening in VivoQuant, and I can still monitor them and make sure that they're working properly, but I don't have to intervene. Yeah.
If there are any questions, please.
Yeah.
Bring them up.
This has kind of been my recurring question.
Okay.
If I like your Onion tool, could you send it to me and I could quickly install it into my version of VivoScript?
Yeah, so you don't even need to install it because it's a script. So it's just a .dqs file, just like a MATLAB file is a .m file. So I would email that to you, and then you would either run it. Yeah, you could run it through here, or run it through the other way that Gabe will show you. But yeah, then you don't need to like install it. Yeah, so if we look at our list of ROIs.
Oh, David, there's another question.
Oh, sorry.
Can you actually set a recording and then do things and stop recording and then put it in the script for you?
It's a good idea.
I
mean, you can, yeah.
Would be nice. We currently have not found a technical solution for it, but it's on our agenda to find a solution for that. We would like to have that.
Kind of like if you have debug set up, then you can have a list of all the actions that you've been doing. You know, technically there would be a way to do that. That's a good idea.
Is it possible to output messages?
Yeah. So,
I'll go first.
Yeah.
Better than the hello world.
So it's right here.
It's a special mode that allows you to pause the script, and while that message is showing, the user can actually use the interface. So that's very useful if you then have, for instance, QC steps, like was that co-registration, has that worked? And if it hasn't, then the user can directly go into the registration tool or move it around itself, and when it's done, click on continue, yes, and then it proceeds. There are also ways to just show a modal message, or in the Onion example that Fiona showed, it also asks you questions like which ROI do you want to work on?
Yeah, so that the question that said which ROI initially was this, well that's an error message, but where is it? Yeah, select ROI to Onion. So it's asking you to do a drop down, and so all of that is already implemented in VivoScript. So here you can see are all the ROIs that were generated by the script. And if you wanted to change the way that they were named, you could modify the script to do that. And then the ultimate goal of the Onion tool would be to look at the signal change across these different ROIs. And so the way you do that would be to open up the table, and you can look at various quantifications based on the ROIs that you drew.
Or you could store all of that back to the
Sure. Yeah. Or write it to a CSV or anything. All right.
Thanks, Fiona. That's great. Okay, so I have really enjoyed the talks today. I wanted to mention that this segment of VivoScripting, we've entertained the idea based on some feedback of having a sort of full day or multiple day VivoScript sort of training session. This is not going to be that. This is going to be kind of a shorter crash course. But based on this, we'd love to hear what you guys think, and if parts of it were particularly useful or parts of it you'd like to see more of, please let us know. So with that, I don't have slides. I'm going to attempt to live write a VivoScript from scratch. So wish me luck, and here we go. So I think probably the most important thing, let me get rid of all my data so I'm not cheating here, is pointing out where the documentation is and things like that. Like if you have a question, what do you do? Because inevitably you will, until you're an expert, obviously. Then there are a few really nice resources that you can have. So one is the help guide. Here's some old figures. So if you just Google VivoQuant, VivoScript, hope I'm still connected to the internet, help, or just VivoQuant VivoScript is enough. The first hit should be the manual. And you'll see our VivoScript manual here. So it's nice to have this open while we're scripting. The next is, as Fiona mentioned, we have a JavaScript-based language. So unless you're a JavaScript ninja, you might want to look for reference. A really nice one is W3 Schools. Let's Google that guy. And this has a really nice reference to the different structures and the programming language itself. I'm not a JavaScript programmer. You don't need to be. And for sort of the rest of this segment, I'm going to assume a little bit of programming background, but not any particular proficiency in JavaScript or the like. And my goal is to hit the sweet spot where people who program a lot aren't too bored, and people who don't aren't lost. Let's see if I get there.
If while you're showing references, maybe you can pick it up on the blog.
Sure, yeah. We have an inviCRO blog. We would love to hear your feedback on it. The Onion tool has a little segment here on a real tumor, in fact, and we tend to update this with VivoScripts that we've written that might be useful to others, and kind of add a little bit of explanation attached to them. So feel free to have a browse.
If you open the Onion tool, I think it goes through step by step.
Yep.
So that's if you're looking for inspiration for things.
Yep. So these are some references. Another really good one is it's always nice to have, I won't do this for the demo, but it's always nice to have a place to start, a script that's already been written. You can find that in your VivoQuant installation folder. So if you don't know where VivoQuant is actually installed, it's typically in C, Program Files, inviCRO, VivoQuant. I have a few versions there. And under VivoScript, there's a whole suite of different tools here. They're explained a little. Some of them are listed in the VivoScript help guide, which I'll add. We'll have a lot of enhancements once VivoQuant 2.5 comes out. We do our best to document, and we're going to continue to do more. So here there are things like segmenting the subject's skin, creating a skin ROI automatically, just loading data, loading ROIs, stripping the skull. Hopefully the names are self-explanatory, but feel free to have a browse at those. Those are always a good place to start. Okay, so what am I going to do today with VivoScript? I'll keep it simple to start out with, and we'll see how much time we have and how far we get, and add complexity as we go. So the way I like to start writing VivoScripts is to do at least part of it by hand first to make sure I know what I'm doing in the application. I'm going to start off simple, so I'm going to load some data, the PET-CT data that Fiona just loaded, and I'm going to create some QC images and just store them locally. And so we'll see how long that takes. Hopefully I don't make too many mistakes. So let's say in particular I'm going to grab, here we have sort of two PET data sets, one that was the original, and then we have a preprocessed CT data set and a preprocessed PET data set where the bed has been removed, they've been nicely aligned, but I'm going to start with something closer to the raw data with the unregistered PET data. I'm going to turn on my classic MIP since that one will look nice here. So I have these nice 4 views. I'm going to put this in my paper or my report or something, so I really don't want that crosshair there. So I'm going to turn that off. I'm going to make sure, I'll keep the patient name and the labels and go from there. Okay, so that was a quick tutorial on how to load data. You can also save images using the Save Image button up here. And I'll just save these to my desktop. You can see a nice little preview up here of what it will look like. Say, demo output. And I'm going to make a folder for my manual QC. And I'm going to, why not, I'll name it after the patient name. So CT, well, I'll call it CT PET.png. And in this case, I forgot to mention, I chose to save all of the different image types together. So if I go to that folder, I can open up all my QC images, see them here, put them in my PowerPoint or what have you. It's not too slow to do it manually, of course, but let's say I wanted to do it for, 100 data sets. I don't want to have to do that. JavaScript, like most programming languages, has a looping functionality. I can loop through my entire iPACS project and just quickly get QC images that way. So you'll start by picking your favorite editor, whatever it may be, as long as it's not Microsoft Word or something like that. MATLAB editor would do just fine. Notepad++ is good, but I'm going to use my favorite in Emacs. And let's see. So I'll start by just in comments. Comment statements in JavaScript are simply done with / to start a comment and / to end a comment. And so here I'll just kind of state my purpose here. What am I doing? Step 1, I'm going to load CT and PET images. And step 2, I will save QC images to my desktop. Okay. So now we're really getting into it. So sorry if that was a lot of context, but I think we're making good time. So the best way to load data from your iPACS, there's one of our developers has developed a really nice sort of external, it's written in VivoScript tool to be able to include and then download data from your iPACS. So the name of it is, it comes with every installation of VivoQuant. I can include iPACS.vqs, and I get all the tools that come with iPACS VQS. You don't have to open this up. There is documentation in the in that VivoQuant installation folder. It's going to be migrated to the true help guide, but for now, it's this text file that indicates a few ways you can use the different functions. So gives a quick overview if you want to include it this way. If you want to create an iPACS object, you do so by providing a URL and a project and a lot of intuitive functions that I'll go through along the way. So I'll use this as my last reference. Okay.
Just as a comment from me, I originally designed the VivoScript, but for me it was really fascinating to see that one of our developers then, went with it and wrote this object-oriented iPACS class that you can then use and make things much more easier. And I hadn't anticipated that people would do that. So for me, it was really amazing seeing how they really went with it and made it more user-friendly with the tool we provided.
Yep. So we'll see. Let me just copy what's over here. And so we're going to do something like this. I need to give it an iPACS URL and a project location. So let me define those as a variable first. So in this particular case, I know that my iPACS URL is this local ugly number because I wanted to make sure we could connect to it easily. But in your case, it'll likely be whatever iPACS URL you're used to using. The one thing is you want to put in a prefix to indicate that it's an iPACS repository. What you do is provide iPACS : at the beginning, and this will automatically be recognized as an iPACS URL. For most of you, you'll have a secure iPACS that you work with SSL encryption. You add a little S here, and this is explained in the documentation. You add a little S here, and it'll be for secure connections. So I'm going to create that and use it here. And then my projects. What project did I load this data from? Demo 2015 Project D PET-CT. Okay. Already forgot. Don't mind me.
Did
I get that right? Yeah. Okay. Okay, so I have my iPACS object. I'm going to get rid of that line. And so now I have this object called repo, for short for repository, that I can then use throughout my script to interact with the iPACS. There's a lot of convenience functions in there. So this basically starts your connection. And it's actually simpler. This is only 3 lines, but it's actually only 1 line, for example, to load data from your local folder. But for now, I'm loading from iPACS. So let's go back to that VivoScript documentation. And so, as you know, on the iPACS, things are stored according to their DICOM header information. So there's study level, there's a series level, and an image level in the way image data are organized. And so similarly, from the standpoint of communicating with the iPACS, you want to query for these studies, these series, and these images. So the first thing we'll do is we already have which project we're looking at. We're going to get the list of studies. And you can kind of, whether on the iPACS or in VivoQuant's data browser, see what that looks like. So this is your list of studies. We only have 1 here. Well, actually, we only have 1 because of this filter. There's a couple. So let's say I only want to get this particular data set for now. There are some nice filtering functions so that I can filter by patient name, for example, and grab what I want. So here in get studies, it says I can call, studies equals repo.getStudies, and there are these potential filters that I can use, filter on patient name, filter on patient ID, and so on. So studies, so grab, load our data equals get studies, and I'll add a name filter. And I believe those were called CT pet /pet, yes. Great. So this should get us the studies. Next, we're going to look at the series. If I want to replicate what I just did, I want to get two different series. I want to get my CT series, and I want to get my pet. The first one, there's only one CT, so that one should be pretty easy. I'll look at my documentation. For get series, I can provide filters, but I don't need to, I do need to for modality to get the CT data set in particular. CT series repo.get series, and it says I need to provide it the study that I'm working on, which I've just received from my get studies object, and then a filter with modality seen there. So these functions all return JavaScript arrays. So they have a list of studies stored as a JavaScript array, and you can index into them with these brackets. So just one thing to remember, if you're a MATLAB programmer, everything's indexed from 0. MATLAB tends to be the exception. So you start at 0, 1, 2, 3, and so on. So studies of 0, I'm going to get the modality of CT. Okay, and now my pet series. Oops, maybe pet. Now, we do have two pet images, and I only want the unregistered one. So I'll also filter on the unique series description we have here.
And you could use the same mechanism also to iterate over all the studies. You know, if you have an array of all the studies available and their JavaScript, there's the for loop.
Yep. Yep. Exactly. So I'm getting one particular one, but you know we can do this in a for loop, and we'll try to do that if we have time. A good practice, I think, in general, is to kind of you know, we're almost there, but let's, you know, if I've done this correctly, I have one study called CT Pet, I have one CT series, and I have one pet series. So now might be a good time to make sure that that's true. I'm going to use VQ's output function. So there are a couple of them. I'm going to show you where those are in the, in the documentation. The way this documentation is structured is you have a number of, there's generally almost all JavaScript functions available to you. You don't have functions that are specific to sort of web things like getting the DOM object and whatnot, but you do have this global VQ variable in all caps that lets you sort of branch in, and that's your starting point. You can get any function in the VQ so this is where you start accessing functions within VivoQuant. There's a nice list of them here. It's a good place to start if you're looking for a useful function. Here you can get sort of parts of VivoQuant that you can then use later. So you'll see here there's the main window, the data manager, the data list, the slice viewer, the MIP viewer. These things you might recognize just from using VivoQuant. Generally speaking, if you want to do an operation on the list of data, you grab the data list, and these things have a mostly intuitive structure to them. The way the documentation is structured is we show the VQ object first, and then we show a bunch of other objects down here that we can use later, such as the main win, and their corresponding functions and what they do. So the question that I had is, how do I print? So very important one. So I can show message. I can use this to show text to the user, as it explains here. There's a slightly more sophisticated version of this called suspend as well, which we just talked about earlier, which lets you pause the execution and kind of do stuff. You actually can interact with VivoQuant. By default, if you just want to print something, you show message. If you want to pause VivoQuant and actually do stuff with your mouse in a semi-automated way, use suspend. So I'm going to show message, and I'm going to say something like found this many studies. So in JavaScript, if you add text, if you start with text and add a number, such as your array length, so the number of studies, then that nicely becomes text as well. At least from what I've heard from my teammates, it's easier to learn JavaScript than it is to learn MATLAB, so maybe that'll be the case for you guys. Yeah, I learned it, so it must be easy. Found this many studies. Series, CT series. At series. Okay, so if this goes as planned, it'll print found one study, one CT series, and one PET series. Now to finally load the data into VivoQuant, we called a function called getImages from this repository object. So getImages is right here. You provide it which study, which series, and where you want to put it inside of VivoQuant. So if you already have one loaded, you could put it in that index in the data list, whether 0, 1, 2. So repo.getImages provide, I'll start by loading my CT image, and then I'll put this in the reference position. And I'll put that in the input 1 position. So what's going on here? GetImages is downloading the data from this study, from this series, and putting it first in our data manager. This one is loading from the same study, this PET series, and putting it second in the data manager. So let's see how we're doing so far. Let's actually run this. Okay, I'm going to get rid of this data again so I'm not cheating. File VivoScript is how you run a VivoScript. Obviously, Fiona just talked about how to put it in your quick script bar. This is usually a good place for stuff you're going to be running over and over again, and want to keep for later. But this is the other way you would run it. So I'm going to point it to my VivoScript. I believe I put here. Yes. ML. Okay. I already have a problem. But this is the way. This is the type of error you would get. So it's saying there's a problem with my get series. The results of the way to read this is essentially that the first argument that you passed to the get series function was not valid. So let's look at why that might be. So get series happens here and here. And the first argument is our studies variable. So something obviously went wrong here. Let's see what that was. So I'll bet if I print my studies length, so from now on I'm going to use Control-Shift-V to be a little fast and enter to quickly run my VivoScript. So I queried the iPACS and got 0 studies. So obviously that's why I'm having a problem. So there must be something wrong with my filter. So the filter here is too exclusive. So it's requiring that my patient name be CT/PET. If I go back, it's not quite CT/PET, it's all this other stuff. no problem. You can add wildcard characters here. So with a star, that indicates a wildcard, and I can load anything that matches this pattern. Okay, so I'm saving this. Let's go ahead and run that again. And okay, I got one study, looking good. Oh, one study, one series, one pet. Let's prepare one CT, one pet. It's even better. And we have our data loaded. All right, let's. I'm going slowly on purpose. I apologize. Hope that's good for you guys. Okay, so now that we have the data loaded, let's get rid of these helper messages. You can comment them out with /. And what was my next step? It was saving QC images. Save QC images.
Good to stay focused.
So let's look at how we would do that in our help guide. So generally speaking, our reporting tools are located in our main window. If you can access your tool not in like an operator or something from one of these buttons or from anything like that, it's usually going to be in your main window object because it's part of your main window. So I'm going to close your iPACS, Eli. Okay. The main window, here we are. Looking through here, these are some of the most commonly used methods, so we keep them toward the top and we try to do that in general. But save image will help you save any type of QC image. Save movie obviously lets you save a movie, either fly through the slices or a rotating MIP. There are a bunch of other convenient functions in here that you should feel free to explore. So save image is what I want. And the way I use it is I provide it a file name where I'm going to store my images, and I'm going to provide it a type. So it says that if I'm in the slice viewer, I give it 0 for MIP, 1 for sagittal, and so on. Tile viewer, 0 for sagittal, 1 for, and so on. All and everything, not the most descriptive wolf. But we know that these match up to my dialog over here. So basically those numbers correspond to which index they are here. This is the 0th one, this is my MIP, this is the first one, or number 1, my sagittal slice, and so on. And we chose to save all images separately, so we'll continue to do that here in our script. So copy that from there, paste that into here, and let's fill this with real stuff. So where do I want to save this? Put equals, I'll just have a place on my folder. Better yet, I'll copy it from my File Explorer. Scripts, no, not here. Well, let's put it in that other folder, demo output, that's right. So I'll create a folder for auto QC. Go on here. You can click up here, copy the path. And now I have a text representation of my path. In general, it's better to have backslashes tend to be reserved for special characters. So it's a good idea to replace your backslashes with forward slashes to avoid problems in text processing in general. So I'll just do that quickly. And I want to give it a place inside that folder. Let's call it ctpet.png again. Here. And I believe I said we were going to save the fifth style of images. Okay. That was only 2 lines. Excellent. Let's go and run it. Loaded our data. What did I do? Can't find save image. Oh, I made a small mistake here, of course. I have to call this from the main window object. So the way you get the main window object is from that entry point VQ that I was talking about. I'll store main window as an MW. It was listed up here, I believe. Oh, here we go. Yeah, main win gets you the main window object. And then I call mainWin.saveImage to actually call that main window tool. Said it saved something. For future purposes, let's also give a nice little message at the end that says, I'm done. And let me check to see if that worked. Okay, I see stuff in here. It's looking pretty good, but you know, we have some problem. We have the VTK viewer didn't show up. We won't. Obviously, we had some other step before that enabled the MIP viewer. And you know what, I'm going to make my life a little harder as well by making the options different. Because let's say you want to give this script to your friend later. Well, your friend has the crosshair on but didn't have the patient name on, and he's in the VTK viewer. So now, how do I get my settings to match exactly what I did before? Generally, these settings are also located in mainWin. For functions here.
Any questions in the meantime? Or?
Yeah, sorry, if you guys want to interrupt me.
Or do you want to make him program something right now? That's a chance.
You have a last minute feature request. 2.5.
Yeah. Yeah, if you could come up with an electronic
crosshair. So I can also just search for crosshair and see what I get. The center is the cursor. Not quite what I want. Oops.
So the type
Toggle.
of file saved is derived from the file extension.
And we support, you know, JPEG, GIFs.
So here, where am I? I'm in the mainWin object. I had missed it earlier. But I can say these functions all set the appearance of different things. So switch the patient name, switch the position labels, switch my crosshair, all these things. And it's a good idea to include them all because, again, if I'm sharing this with my friend, I want my friend to see what I see. So before I save anything, I'm going to call these functions. So mainWin.switch patient name. I give it a Boolean, which is true or false, which you can represent by writing true or writing false. So I want my patient name on. I want my position labels off. I want my crosshair on, or sorry, off. Sorry, this one on, that one off. Okay. This off.
It would, for instance, be possible, we have done that in the past, to write the VivoScript that produces this code for you. And you know, it's possible to output text from VivoScript. So if you have to do this very often in different configurations, you could just write code that looks at your current settings and then write out code that reproduces that again. That's something that we've done occasionally.
Great. So, and yeah, that comes closer to the macro operation that we were discussing earlier. Now you guys, if you guys are not familiar, you know, there's the VTK and the MIP, the classic MIP viewer to be able to project your data in a volumetric way into slightly different views. They each have their advantages, and that I look forward to streamlining that a little bit in 3.0. But you can toggle between them using a function called enable VTK. And you want to think of what sort of owns that MIP viewer. And in our case, we know that it's I'm telling you that it's the slice viewer, but kind of intuitively, you know that the MIP shows up in the slice viewer, and that indeed, if you get the slice viewer object, you're going to find an enable VTK function that toggles it on or off and switches between the two for you. So let me call it out in my script. I don't have a slice viewer yet, so let me store that. And then slice viewer dot enable VTK off. Okay. Let's see if I made any mistakes. How am I doing on time?
Correct.
Great. Oh, look at that. That's looking pretty promising. It turned off my crosshairs. It turned on my MIP. Let's look at that output. It's looking pretty good. Okay. Fantastic. How much time do I have?
15.
15. All right. We can do something else. Oh, yes.
Automatically saving your center slice, or?
We're looking out in the sense that, VQ, when you load new image data, it automatically centers it for you. But you can either set positions using direct numerical values, or, for example, the 3D ROI tool has a sort of center of mass tool to find the center of mass of your ROI. And so one script that's pretty popular that we do is we call that function to get the center of mass, then set that position of the crosshair, then take our QC image, and then do that for every ROI, and then we get a nice little centered picture of every single ROI that I've drawn or automatically segmented. So let's do a for loop so that we can show you how you might batch process this. So our other data set is only a pet. So the one issue we have here is now I have different numbers of data sets for each one. And that's fine. But let me open this one just. What's going on? Not good. Let's make it a little simpler and say I want to take individual. Let's loop through my series then, since we're having a little trouble with this study up here. Let's loop through all three of these series and take each one individually.
Why don't you say the mid-movie of each of them?
Sounds good. I'm getting live instructions. Okay.
If you have any requests,
Confirm the magic segmentation button.
So we're in a good place because we already have our studies. As I said, the studies object is an array, a JavaScript array. So I can use a standard JavaScript for loop to iterate through it. The syntax is for. I'll start by writing it out. So this is kind of the first line. The first statement, all statements are separated by semicolons, and the first statement sort of initializes our counter. So this little I variable is going to store what number we're on at the time, which study we're on, and we're going to iterate until this middle statement is not true, which says that I is less than the length of studies that I have. Okay, and we're incrementing. Hopefully you're familiar with this sort of syntax. So now instead of studies of 0, oh sorry, I should be iterating through series. So let's do that. Get series studies 0, and this time I won't put any filter because I just want all of them. And let me get rid of my pet series. I'll just comment them out for now. And so here's where I loaded my data. So this time, instead of loading the CT series and then loading the pet series, I'm just going to load one. I'm going to load based on the index here. So this is now called series. And I'm going to get the I series. I'm going to put that in the reference position. So it replaces it every time. And then I'm going to do all of this. I'm going to save, toggle my, save an image with all my favorite settings. And close the for loop here so that this whole block of code from here to here is going to get run for every single series. Now, obviously I don't want them named the same, so maybe we can do something like get the series description and put that in the name itself. These little array objects have that directly built in, so it's pretty convenient. So here I'm going to sort of splice this string, and in the middle I'll put series of I dot series description. And these purposefully match your DICOM tags. You could do a number of other DICOM tags are supported here as well. And maybe I'll do write CT pet here now that I know what it is. Do series. I need to remind myself whether modality is in the study level or image level. It's in the series level. Perfect. So series of I dot modality. Okay. Well, let's see if that works. Okay, I only loaded one CT data set. I'll load one PET data set. And then another PET data set, so that's looking pretty promising. Let's see what that looks like in our names are all messed up. So I obviously referenced those things wrong. Let me see. So for one thing, those undefined is by default what you get in JavaScript if they're if those objects sort of didn't compute properly. So they got overwritten with the very last pet, which is kind of what you expect. Those are our old ones. Let me trash those so they don't confuse us. And now I'll trash these. And so what was wrong with my names over here? Maybe the capitalism. What's that?
Maybe that's a good
This is 2.1. Yeah. The nice thing is if you're familiar with debuggers, you can use that in 2.5 very easily. So I believe it's the capitalization, but let me check here in one of my documentation. Sorry? Oh, great. Okay. Lovely programming details. It's just capitalization. As a last form of resort, which you should not hesitate to use, please feel free to contact support at inviCRO. If you're looking for a function, it's not explained well enough in the documentation or whatnot, we can field some of these questions that are more advanced. Okay, let's try that again. Can start seeing them populate here. Oh, that's looking pretty good. I'm done. Yeah, look at that. We got CT, the pet with the preprocessed pet and the unregistered pet. Let's make sure those look okay. Pretty good. Oh, I think I promised rotating MIPS. So, well, that was save movie, right? Let's do that. Save movie, file name, type, just like save image. So with 0 for the MIP, perfect. So I will go, and this time save movie. What do I want to save this as? Let's call it MIP. And
PNG.
oh, yeah, thank you. So PNG is not a movie format, so we'll use an animated GIF.
It's possible, but then you end up with all the frames.
Yeah.
Which might sometimes be what you want.
Yep. And things worked. We should see a rotating MIP here. That's pretty nice. See what's popping up over here. Great. Okay, that report ready. One more is being done. Okay, fantastic. I think that brings us close to the end. Let's stop there, and I'll just describe a little bit of what else you could do. You could go through the different operators. You could use them to segment automatically. You've obviously seen what the Onion tool can do. You can save things back to the iPACS, either as an image, or you can save them in your web disk, just as simple files. Like you can save these QC PNGs in your web disk side and use them later, or have them be indexed or previewed with our nice iPACS 2.0 GUI, and many more. We've really done kind of everything that you can think of, at least at inviCRO, on VivoScript. It's typically the preferred way. We're also a MATLAB shop. We use that pretty heavily, but and Jacob has told me that we greatly outpace MATLAB use by VivoScript use, at least at inviCRO, and that's part of how we can generate that large ROI number that you saw earlier today. So thank you. I'll take any questions.